So I think it's time to start. And hello, everybody. This is a RADEXT session, and I'm Valery Smyslov, and my co-chair is Margaret Collin, and we are both remote this time, and so Alan is working group delegate at this session, and so hi, Margaret.
Hello?
I think we can start. So. As usual, this is a note well, and just remember that this session uh, is been recorded, and all your contribution during the session are subject to IETF policy. And this is living IETF code of conduct, so please respect others, other participants. And then we need so this is meeting details, and we need to do some administrative tasks. And first of all, we need two note takers. So any volunteers? I just can't see the room, so Alan, if you...
Yeah. Any volunteers for note taking? Ethan? I can take notes too, Valerie.
Okay. So this is an agenda for the current session. We have not many presentations today, but one of them is very important, and the others as well. So, any agenda button? Going once, going twice. So, let's go. So, first presentation is a short update on the working group documents. So, Alan.
Yes, I had sent some slides over. We can see them. The deprecating insecure practices document has lots of clarifications after IETF 120. Some clarifications on the blast radius issue based on vendors reading or not the document, or not reading the document. Question I have would be, do we want to do a working group last call? I don't know there's a lot more to do on that document. There's the TLS PSK, it's document. It's been submitted to the ISG for publication. We've had some discussions recently here, some GitHub pull requests, and some discussions on the list about clarifications. Things like we probably do not want to recommend session resumption when TLS PSK is used because it doesn't really add anything. There's some text about that we need to discuss, but it doesn't materially change anything in the document. And then the Radius 1.1 document has been submitted to the ISG for publication. Lots of reviews from lots of different people. And I believe there was some initial attempt at interoperability. Heki, do you have any comments as to how far that got?
I just want to add
You want to go to the mic?
that radius we one
You don't hear me. Oh dear. Can't
okay.
hear me? I'll talk in. Is that better? Okay, I'll really got to lean in. Sorry. Yes, Heki.
Yes, this is Heikki Vatiainen. So I did what the draft says, and I removed all the attributes like message authenticator and user password obfuscation. Some amount of code, and well, I tested with myself. I haven't tested with, for example, with FreeRadius yet, as I understand there is an implementation there. But I didn't run into anything that serious about it. So if there is, for example, if a home, if the next hub destination, if you are proxying with the realm and there are two RADEXT servers at the other end, one could be radius 1.1 capable and the other one is not, but I didn't see anything suspicious there or anything that why it wouldn't work. But I think now we can do some more testing soon.
Okay. Okay,
Yeah.
that sounds good. So at least some progress on interoperability, and hopefully within a month or so, we should be able to show multiple interoperable implementations, which makes a big difference. And that's it for me for this status updates.
And
I
would,
just wanted, before we go
oh,
on from here, can we just, if there's any, we were talking about sending deprecating radius to last call before this meeting. I don't want to do it during this meeting, but is there anyone who objects to doing it right after this meeting? Anyone have any concerns? Because otherwise we'll just go forward with that. There are changes. It's worth reviewing again, but I think we can do that in last call. Anybody? If Alan, you can look at the room and tell us if anyone's raising any hands. Any concerns? Anybody online have any concerns? No. Okay, so I'll just do the last call. I'll probably do it very soon, but make it be 2 weeks after the IETF meeting because obviously people are busy and traveling. And we will get that hopefully out to the ISG soon. That's it.
And I want to add a few words about the status. And draft radius V11 has passed ISG evaluation, has sent to the RFC editor. So it's the final stage before the publication. And draft radius TLS PSK has passed the ISG evaluation and is in the status ID follow-up. So it is waiting for our ID decision to finally send it to the RFC editor. So at this point, we have a few pull requests for this draft. And I think that from procedural point of view, it should be discussed with our AD, with Paul, whether to merge these pull requests or not, because the draft is about to be sent to the RFC editor. And so if our AD decides that these changes are major changes, then this probably will require the draft to get back to the working group, to pass a new working group or last call to get a consensus, and then a new IETF last call that will, and new ISG evaluations will postpone the publication process. Or perhaps after the discussion with our AD, he decides that this is not controversial changes and he can approve them at this current point. So
Right. If there's anything substantive, we at
yes,
least should run that by the working group for a week. And then it's up to Paul to decide if it's substantive
yes,
enough
yes,
that it's another ISG
yes,
review.
yes, agree. But the final decision will be from Paul, whether he approves the changes or thinks that, I don't know, the new ISG evaluation is needed. So that's what we have with this draft.
Okay, this is Alan. Yeah, I'll summarize the discussions on the mailing list and propose some changes, but I do not think that the changes are substantive. It really is some clarifications on the use of resumption. So it's 3 or 4 sentences, maybe a paragraph at most, which should be okay.
Summarizing on the list is great. That's how we run it by the working group, so that's good. And we will talk to Paul, but if that's the only topic that there's changes on, it's we'll probably push for just, having it go through. So make sure you include everything that's changed since the draft the working group reviewed. Just we don't want there to be any last minute surprises.
Heikki?
Yes, this is Heikki Vatiainen. So just one thing that I've thought about the deprecating draft is that can we maybe make it a little bit shorter? It has grown. I think it's the longest draft that we have open. So maybe sharpen it a little bit, or I need to take a closer look, but it's 50 something pages.
it's huge.
Yeah.
Yeah. So the document is very, very big. It doesn't even cover everything that's wrong with Radius. That's in the wiki. It just covers security issues. I think the blast radius stuff added about 20 pages, and it goes into it in excruciating detail. And there's still a number of vendors that got things wrong, and we're still trying to work through that. I'd like it to be shorter, given the fact that people don't follow the recommendations. I think it's good to leave. I don't know what else to take out of it, I guess. I mean, I see your point, but I'm not sure what to do.
Okay.
I actually think there's a lot of value in documenting the blast radius stuff there in what will be an RFC. And so I would object to taking that part out. I mean, it could have theoretically been a separate draft, but I don't see the point. And I definitely think it's valuable to document it in an IETF context where people might find it if they were looking for, why shouldn't I run Radius UDP, or how can I run it securely?
Jenfred.
Yeah, this is Janfred. Maybe as a suggestion to solve that problem would be to move some of the explanation of issues to the appendix and have the actual normative text of what you should and shouldn't do in the normal text, and then have all the explanation of why blast radius is a problem and why some of the solutions work and some don't in the appendix. So everyone still has this as part of the RFC, but the main focus on the RFC in the text before the appendix is actually do this, don't do that. And if you want to know the reason, look in the appendix, but the text of the actual RFC is a bit more straightforward, because right now I can imagine people looking at that document seeing, wow, that's 70 pages of best practices, and going, I'm not going to read that. I'm just going to do whatever I want to do. And that's not what we want, I think.
Unless something has changed, what to do and what not to do is very clearly in the front of the document. I don't see the value of labeling sections appendix. It's not a standard. It's going to be an info document, isn't it? I don't remember its publication status, but I mean, it's not a standard, is it? If it is, then I don't know. I guess it needs to have.
Yeah, it's standard track.
So does it have must, may language in it?
Yes.
Okay, so I mean that's the normative stuff. I mean, if you want to, Alan, put stuff in an appendix, you can. I feel like we've spent a lot of time on this document for what is a very simple message. And I'd like to get it out because I'd like people to, start acting on it. And I'm already getting people asking about it in, where I live. And, it would be nice to have an RFC to reference and be able to tell people, due to this RFC, we recommend this behavior. And it's easier to do that with a document that isn't moving.
Yeah, I'm okay, I guess. Maybe with moving things to an appendix, the issue I find is if you just have lists of must do this, must not do that, people don't understand why, and they just ignore it. Whereas if you have explanations of you must do this, and when you don't do it, the world ends. Oh, okay, it's a little easier to get that across. But Yanford's comment in chat is maybe it could be a BCP. I'm okay with that too. I don't know that it needs to be. Maybe it does need to be standards track because it's doing things like deprecating MS Chap, right? And saying, dear God, don't use MS Chap. It was broken 20 years ago and we have no idea why we didn't deprecate it before this.
Yeah, that's true. If it's going to update standards documents or obsolete them, I guess it needs to be a standard itself.
Yeah, so this is Jan-Fred again. Yeah, so I've just had a look at the RFC that deprecates TLS 1.1 and 1.0, and that's a BCP. So I think BCP should be the or would be the right document class for that. And regarding the explanation of what's wrong, I think it's valuable to have it, but I would try to shorten that explanation to the minimum text necessary in the normative section and then have a more lengthy explanation in an appendix, because that probably will give people more incentive to actually read the text. I haven't read the new version of the document yet for that exact reason. It's very, very long and I haven't had the time. And I think the metric we had at the hackathon was Heike mentioning that my draft was exactly long enough to go over in the flight from what was it, Helsinki to Dublin, and I think your draft is a bit longer than that flight.
And for completeness, I want to add a few words about the two Romanian working group documents. It's a rare score and status real. So the both have very little discussion on the list so far, and one of them get expired. So I ask working group participants to review these drafts. And first of all, the expired draft need to be revived to get to life, and then discussed and the move these drafts forward.
I don't like to both chair a group and edit a draft. So if one of my other authors on Status Realm wants it to move forward, they should do that. I don't feel comfortable doing it and sharing the group at the same time. Jan-Fred, are you?
Jan-Fred? Oh, Mark. Okay.
Your mic's off, Mark.
Sorry. Yes, I had it kicked into my head a couple of weeks ago that this has been languishing, and I am starting to do work on it again. If anybody has any comments, that I would fully appreciate it, but I intend within the next 2-3 weeks to at least put a status updates to the mailing list on this.
Yeah, and this is Alan again for the other one, the reverse COA document. I think that's essentially done. We could do a working group last call. There are, turns out, multiple implementations. Aruba supports it on their access points. Cisco, I believe, supports it. There's at least one server implementation. There's been no substantive comments when there was a lot more people reviewing the draft. So I'm cautiously optimistic we could just do a working group last call and move it forward and be done with it.
Does anybody have any concerns with that plan? Anybody want to jump up and say they think this document isn't ready? for working group last call?
I'll ask, how many have read the reverse COA document? 1, 2, 3, 3.5. So
Well, hopefully if we get it to working group last call, a few more people will actually read it before it goes out.
Hopefully.
I mean, multiple people bothered to implement it, so possibly all of them were just in the room and raised their hands, or maybe there's a few other people we know read it because they aren't here. I can't tell.
Okay, then I think we can move to the next presentation. So, Jan-Fred.
Yes. Radius DTLS, the never-ending story. Yeah, so short update. You can go to the next slide. What happened since the last IETF? We had a lot of discussions on the mailing list, which was great. And we had an interim meeting in October, about 1 month ago, where we discussed open issues. Fabian, Ethan, and some others were busy submitting pull requests on GitHub. Thanks for all the comments that happened there. I think we moved forward on most of the issues, but some issues are still there. If you can move to the next slide. Yeah, so the results of the interim, just to summarize them again, we had a consensus, at least in the interim meeting, that anything regarding proxying, load balancing, anything like that, should be deemed out of scope for this document, because that's general radius and we are only dealing with radius TLS, DTLS here. That includes the question, what is actually the same server? That was one thing that was in the original RFC 6613, I guess, radius TCP. We still need to see if we have some, if we should have some text for server name indication. But I think this one is more closely tied to dynamic discovery, because that's where we actually may need server indication. I'm not sure if it should go in the general document. And probably we should have a new radius lessons learned document to, yeah, for all the proxying and load balancing considerations sometime in the future. Dealing with unwanted packets, so we still need some more thought on that. I think we haven't really gotten a consensus on that one yet, especially also because I work in an environment where we don't have radius accounting, and the core problem there is that with radius DTLS we use the same port for accounting as we use for authentication. So we need to have a way of dealing with unwanted accounting packets, because receiving them and then just dropping them might not be what we want. This is not an issue unique for radius TLS, but yeah, since we have the same port, we should say something about it. There have been some suggestions. Some of them rely on non-standards track documents. Would be a downref. We just need to have an opinion on that to move forward. Next slide, please. Yeah, one very interesting issue is the selfie loopback. I don't know what exactly it's called, attack. The precondition for that attack is that a server acts simultaneously as a client and has aligning configurations so that if the server or if the radius peer as a client would connect to itself as a server, it would accept the connection, because either they have the same TLS PSK configured for both directions for a client, and then an attacker just mirrors all the traffic back. Or if you use certificates, then the server would accept its own client certificate and the client would accept its own server certificate. That scenario is or could happen in dynamic discovery scenarios where you have where you don't check the server name, but only a specific OID that says, yes, I am an open roaming radius or RADEXT client. And the server also has a certificate that says I am an open roaming RADEXT server. So it would probably accept its own certificate, which could cause a loop. Loops are bad, and Radius itself doesn't have loop prevention. So we may have a problem, and this is a general problem for TLS. But for Radius, it's more specific because we have these Radius packets that we can just proxy. And usually you have a different meaning in other protocols. Next slide. So we had some discussions on the countermeasures. The option 1 presented first was to just check if the server certificate presented is the same certificate that the peer has configured, which might not be what we want. The second countermeasure suggested was to check if the client random that you receive when it as a server is equal to a client random you just sent out. Fabian implemented that in RADEXT proxy during the hackathon and said it was very easy with a few lines of code, OpenSSL callbacks. So that's possible, but that countermeasure may not be forward compatible if we some new TLS versions come that completely change the way the client random works or something like that. Yeah, so the third option that I came up with at some point was maybe you could use a status server message as a first message you send and include a peer ID, maybe in a newly defined radius attribute, and the server can check it. And if it's the same peer ID that it generated on startup for itself, then there's a loop. That could also help with loop prevention if you give the same ID to all of your servers in a load balancing setup so that you don't bounce back packets between those load balancing servers. Would require more specification, more implementation. I'm not sure if that's the best way forward. I think the only way that we can actually solve this problem is some kind of radius routing protocol, and I'm leaving the room. Okay, so I'm not really sure what's the best way forward here. I'm open to hearing suggestions on that one because all of the options have advantages and disadvantages. I'm just not sure.
So this is Fabian. I think I already put that on the list. All the measures we propose here are only first-line defenses. So they mostly work on direct connections to oneself. As soon as we have more than one radius hop in proxying, all these things break down. What we have, I believe, is in the status realm draft. There is a loop prevention proposal. I haven't gone over that in too much detail, but assuming that one works, all we have to do here is kind of show what you can do if you have TLS, kind of first line defenses, but they are all really optional. They don't solve the final problem. That's in the future draft. But I still would put in kind of recommendations what you can do if your TLS library allows. If not, you're kind of out of luck if you have scenarios where you need kind of same certificates that you can't verify any further. Again, I think the TLSBs already states verify server identities as much as possible. If you really have a scenario where you can't do that, you're out of luck. You should do some loop prevention. But again, the final solution should be the status realm loop prevention, including multiple hops.
Next in the queue is Jonathan.
Hi, I don't know if you can hear me.
Yes.
So I think the correct or the TLS answer to this would be a mixture of option 1 for certificates and RFC 9257, which was the RFC on how to generate a peer ID such that you don't get this problem. Or how to make your secret different such that even if everyone shares the same key, you don't have this problem. Have you looked at RFC 9257 and said that doesn't work here, or have you just because that seems to be very similar to option 3?
Yeah, we've looked at it.
What doesn't work there?
We just haven't looked at it until recently, so we're still figuring it out.
At least for me, I can say I also haven't really looked at it yet enough due to reasons. I'll definitely have a look at that.
But yeah, so my suggestion would be option 1 and option 4.
I'm next. Let me find my notes. For the TLS or the issue of bad packets over the connection, I think we should do the same thing as the proxy issue, mention it and run away. And just say there's nothing we can do to fix it, and perhaps future documents can address this. I'd also say loop detection is outside scope of this document. Mention it, push it off to status realm. And the only other thought I have for this document is, detecting the selfie attack or self loops. One other option would be that if your inbound identifiers are separate than your outbound ones, then you should be able to trivially check this without doing much of anything else. But that's more of a policy thing and requires the administrator to do something, where the options here are a lot more automatic and done without administrator intervention. Oh, and one other thing I think Fabian had mentioned in earlier when we were discussing for DTLS, we also have the issue of the TLS records versus the radius packets, and this is perhaps also a question.
That's the next slide.
Okay,
but
I'll be quiet.
Finish that iteration here and then go to the next slide.
Hi, Alex Kluter. We've been battering around, chatting in the hackathon about RFC 9275, 57 and 58. We were looking at the way generating IDs to try and figure out whether you're a client or server, and the suggestion, one of the main routes in there was having a using almost host identifiers, or I guess even an IP address, you could say. But we don't get some of those options because we're now having to distribute that to all the clients anyway, so they can figure out who's who. And if you're distributing those IDs between systems, you might as well just use unique IDs. And for us, with things like any other client identifier, it might not travel for us from one box to another anyway and be preservable. There was something else as well. Oh, that was it. GNU TLS is the only thing that implements an importer that's usable here, whilst everything else doesn't. So it's a bit unclear how to go forward on that.
Well, a tried and true method in the IETF of going forward when you're not sure what to say is to say nothing. It can be mentioned, like in the security consideration section, that, I mean, if we can agree on something to say, we should say it. But if not, we could say in the security consideration section that this is an attack we're aware of in TLS, and, you know, say that, you know, it's not, we need to look at that RFC and do all those things, right? But if it's true that there's not a thing we can say about this, we could say this specification does not change radius DTLS with respect to that attack, and therefore is no worse than what already exists. And we could, as a working group, take on a separate effort to figure out what to do about that attack if we think we need to. Or we could wait for TLS folks to figure out, you know, what applications should do, and then we could write some guidance about how Radius should do that. It's not necessary that we solve every new problem that comes up. If we do that, the document will never go out. So, so think about it with respect to that RFC. Think if there's something we can say. If you can't come up with, like, everything doesn't seem like a good answer, document the fact that we didn't answer it here and move on. Because what's out there right now has this problem too. All right, we're not creating this problem. We don't have to fix it.
Okay, so I think I'll take this and look at the mentioned RFCs and update the draft accordingly. Okay, so the next slide. That's what Ellen already mentioned. Hot off the press during the hackathon, we had a look at the document again, and then noticed that we don't have an explicit specification how radius packets are put into TLS records. The implicit assumption from other text is that for TLS, we treat everything just as a constant stream of data, and we find out the radius packet borders just by looking at the radius header and comparing the lengths, which is also the reason why once you have a radius packet with an invalid length, you have to close the whole connection because the borders won't work anymore. For DTLS, the implicit assumption is that we treat each DTLS record as one radius packet, which is kind of sensible because each UDP packet had one radius packet in it. So the specification is on the receiver side, but we have no specification on the sender side. And the specification on the receiver side is not completely clear. So we definitely should add some explicit specification on how to send the radius packets for DTLS that says one radius packet per DTLS record. For TLS, it's a stream anyway. We don't need to specify anything explicitly. We could specify that it doesn't matter because we treat it as a stream on the receiver side anyway. Yeah, but that is an interesting thing because we looked at the DTLS specifications and did not really find a well-defined interface that lets applications define where the record ends. It's kind of implied that this should be a good thing because DTLS is allowed to drop packets in between, and it should still work. But we're not sure that every library actually does this. Maybe some TLS library does some very obscure magic that doesn't deal with this in the same way. So the question here is this a good thing to do, or did we miss something, and are there dragons we're not aware of?
Mark.
I would be careful about saying one UDP packet, one DTLS packet per UDP packet, because UDP packets can be fragmented. And I think you'd end up with one DTLS packet per fragment, but I'm not 100% sure. I did work on a DTLS protocol before, and there was trickery around how to make sure your DTLS data that's sensitive doesn't get sent before you've established the whole security thing, which I've been told has been fixed in current libraries, and I hope it has. But also about do we, what happens when UDP packets need to be fragmented, and are we going to fragment the DTLS packet? I don't know how that works. So we should make sure that we're sure of how UDP fragments are handled in DTLS so that we make a correct statement about where the packet ends.
I think that the fragmentation is completely independent from the DTLS records, because for radius UDP we also have the rule 1 UDP packet per radius packet, but if the radius packet is longer than the MTU on the link, then the IP fragment will get the IP packet will get fragmented, but it will still be reassembled as one UDP packet on the receiver side. And DTLS has a similar fragmentation mechanism built in.
Yeah, but DTLS has some fragmentation mechanism built in. And then it runs over UDP, which has a fragmentation mechanism.
So I'll jump in here. I'm next in the queue for precisely this reason. The DTLS record, which is the application data, is independent of the outer UDP fragmentation. So there may be multiple DTLS packets, but when your application says, get me my data, it will get either a full application record, let's call it, or nothing. And after some searching around, it looks like this is documented on a GitHub issue for OpenSSL. And the comment is generally, if you do one right, you get one TLS record, and OpenSSL or the DTLS implementation should take care of getting either all of your application data in that record or none of them.
Okay. So when you get a DTLS frame at all, it's always going to be the full set of UDP stuff that was sent to DTLS for one request. I mean, the wording I'm worried about, because it's not, there's the UDP packets and they may be fragmented. There's the DTLS packets, for lack of a better word, and they may be fragmented. And then there's what you sent in a single block.
But
right? And
the DTLS library on the receiver side will always get you either the full DTLS record that was sent or nothing. So if there was some fragmentation on any layer between the application and the IP, then either it worked and the DTLS library will get you the whole thing, or it didn't work, something got dropped, and it will return nothing because it's missing something.
Okay, well, that sounds good. As long as we use the words that are consistent with whatever those things are actually called in the DTLS spec, then that should be good.
Yes, so this is Fabian again. To reiterate, the DTLS spec says that one TLS record must fit in a UDP datagram. The UDP datagram might get fragmented, that's fine, but one TLS record must not span multiple UDP datagrams. There can be multiple TLS records in one datagram, that's allowed, but it must not span. Regarding our issues here, I try to kind of find references from other protocols. So, for example, syslog defines that a syslog message can span multiple TLS records. I find that as not a good solution because of reordering and packet loss. So I would fully agree of defining that one radius message must fit in exactly one TLS user record. And if your DTLS library does not provide for that, kind of too bad, because if it were otherwise, we have a non-solvable problem of reordering and packet loss. The other thing, whether how to handle lost or not lost, but garbled packets. My take is that because we have integrity protection, if you receive garbled DTLS user records, anyway terminate the connection because it has to come from the known server, and if it sends us garbage, there's something wrong and we should close the connection.
Yeah. Hecky, you're still in the queue?
Is this Heikki Vatiainen? So I was just thinking that radius UDP, when you read a datagram, you get one radius message. If you get, and then you take a look at the radius header and see that what the length is, and the rest is padding if it's longer than what the header says. So with DTTLS, do we do the same thing? So for example, if I read 2000 octets from a socket and the radius message says that this is 1000 octet long message, is the rest padding or is it possibly another message? So do we make it, is it sort of analog as with the UDP radius, or do we do like in TCP or TLS transport that we read 1000 octets and then consider the next 1000 octets, for example, the beginning of the next radius message or the whole message, depending on what the header says. So one DTTLS record, does it carry more than, is it possible for it to carry more than one radius message? Or does it work the same for DTLS and TLS, so you can sort of stream it over the DTLS or TLS records?
I'm not exactly sure what 7360 says.
Says nothing.
Yeah.
Yeah, I'm actually in the queue, so I'll partially answer that. The answer is would have to root through the OpenSSL implementation to see what it does, because I'm pretty sure none of this is answered in the DTLS RFCs, and it's certainly not discussed in 2360, which defines radius over DTLS.
There's also that was what I was thinking of was the receiver side. So when a server has two radius messages, it needs to send over a DTLS link. Can it just concatenate them together and write them to the DTLS socket? Because there's framing radius, so the receiver can then chop it in two and have the two messages with one read.
For me, I'd be okay with that. The issue with UDP is no one really knew what the heck to do with it, so it was just banned, right? For DTLS, it's all signed, encrypted, whatever.
Yep.
So great, it should be allowed, but we should check to see whether or not it's actually done inside DTLS. I would hope that each UDP write or each application write is one TLS record, but I don't know for sure.
I think it is because
Yeah.
otherwise,
I mean,
if you have
then we would have the option to say each DTLS record is one one radius packet, and then you could stuff multiple DTLS records in one UDP packet.
Yeah.
So then on the receiver side, if OpenSSL or your SSL library actually has an implementation that allows you to get the whole record, then it would always be, get me the record, this is a radius packet, and everything longer than this is padding.
Yeah, the belief then would be that, yeah, you call SSL read or whatever, and you get one packet which was written via SSL write on the other end.
Yes.
But we have to check.
Yeah, so I think it's a little bit of also that how we want the applications to work. So if we give them permission to send 2 radius messages with one SSL write.
Sure.
Yeah.
I'll also add that I was talking with Eric Vink before this about these kinds of issues, and that we're defining TLS for radius. There's a TACAX TLS document, and he pointed out that I'm the Utah chair, which is using TLS in applications, and if there are multiple applications using TLS and having the same problems, then someone resembling me should write a document that addresses this, having gone through all this pain in multiple groups now. So that is likely useful.
Hello, Alex Kluter. When we were splunking through the OpenSSL documentation, as well as the RFCs about DTLS, it wasn't until you kind of went back to version 1 of DTLS did it sort of talk about the mapping from application down into it records. And from our perspective, the reading is straightforward. You will never get more than a single record from an SSL read. So that's okay. So what goes into that record that you're stuffing in? So I think we need to firm up that you must make sure you write your whole radius packet in one big go. You don't, like, we should explicitly say that, because then you'll run into the risk where they will be in 2 records and then all hell breaks loose. I think the fly in the ointment was maybe they firmed it up in a later draft and we just didn't find it. But the earlier draft said SSL write will grumble at you if you do try to write more than the MTU. But it says it should grumble. so you're like, okay, this is going to make it a bit more fun. But it does look like one write will map to a record. It will then, as Fabian mentioned, it will then bundle as many of those into a datagram that it can. And the reads, we're safe on the reads. It's the writes that's where it gets fruity.
Yeah, Fabian again, just to comment on that. I tried it this afternoon, and at least OpenSSL will not complain. The DTLS RFC says you should not allow the application to write more than the MTU. OpenSSL doesn't care. It simply writes whatever you send it, possibly getting UDP fragmented up to the maximum TLS record length. That's the only spec that OpenSSL does. If you hand it over more data than the TLS record length, it will put it into multiple records. Other than that, there is simply no check at all.
But it will not complain that you just gave it more than it could chew.
No. Well,
wow.
It will chew it. OpenSSL doesn't care. It will
but in multiple bytes.
in multiple bytes, but it will not complain.
So, I mean, this is some of the stuff I had mentioned a while back about you can kind of say just send stuff over TLS, but you can't say just send stuff over DTLS. Is you have to make decisions about these things. And there are, I think it would be fantastic if the person whose name I didn't catch were to write the RFC that explains how to do this or options for doing this or whatever makes sense, because we spent a bunch of time figuring this out for earlier DTLS protocols. And I think hopefully that person can help us figure out what to write down for this one.
Eric suggests that would be me.
Which Eric?
Eric Vink, one of the ADs.
Right. Okay. Then we should definitely talk to him and get the right wording for what's going to actually work in a, because I mean, it's nice that OpenSSL does it, and I realize probably all of our current implementers are going to use OpenSSL, but we want it to be right for the SSL spec, because we don't want somebody else to have written a DTLS that's compliant with the spec, but we can't use it because we specified you have to do things that the spec does not actually guarantee are available. So
yeah, so I think we will take that with us too, which makes my next slide kind of obsolete. I don't know. What are the next steps? And the last big bullet point there is what else is needed for working group last call. And I think we're still not ready with this document, and it's moving along, and I really like it, but it could have been moving along a lot faster. Of course, for me, my next steps will be to include the reviews from the feedback from the reviews from the interim and now from here. There are still some open to-dos in the document where I just haven't had the time to think about the right words to say. So my plan to fix those to-dos is until end of year, definitely before the next IETF. But then, of course, the question would be what is still needed to have this document ready for a working group last call. And the more I look at it, the more I notice changes that we made from 6614 and 7360, so the original experimental RFCs for Radius TLS and Radius DTLS. And I think all the implementers should look it over again, compare the old spec to the new spec, and see what updates are needed in the implementation and what updates are needed in the configuration. And then, because 6614 had an appendix section on how to configure Radiator in a way that is compliant with 6614, because I think Radiator was the first implementation of Radius TLS when it still was called RADEXT. And I think we should have such an appendix in the new Beast document as well. So any changes in configuration or how to make existing implementation standard compliant should go in there. But yeah, lots of changes. We need to make sure that we understand every one of these changes, and every change is actually implemented in the existing Radius TLS and DTLS implementations that we know of and that we can control.
I think 4.5 months is the next IETF. I don't want to wait for that to be a revision cycle. So I'm wondering what people think of having another interim meeting between these two to do like we did last time, walk down all the known issues. What is the proposed solution? For your to-dos, you could show us the proposed text and try to keep the document moving along a little further. Jan-Fred, would you be willing to put in that effort if other people are willing to attend?
Definitely.
Anybody have any thoughts on whether it's a good idea?
Anyone in the room raise hands? Think it's a great idea? We'll attend.
I think it's a good idea.
1, 2, 3, 4, 5, 6, 7. So yes, 7 or 8 people.
That's
good interest.
Plenty, given that Jan-Fred already said yes and didn't raise his hand, and Valerie and I said yes. I mean, 10 or 12 people is a good enough chunk of this working group. It's not like 3 people in a room. So let's do what you can in the room, right, and talking with these specific people. But let's plan to do that sometime in you know, the February-ish timeframe. We'll figure out when people can make it and do a poll and everything. Try to plan it maybe a little further ahead than last time. I'm sorry about that. But we will see if we can get some good times for people. It just happened to be that the certain people who had to be there had such constrained time between then and when we needed the document out that it was very tight. So maybe a little further ahead this time and see if we could get a few weeks that might work, so we have more options for the whole working group between now and, you know, before we have to get documents in for March.
Yeah, so I think that was my last content slide. The last slide is just the normal DFN finishing slide. Yeah, so unless there are some other open issues that I have not yet noticed and are not that documented, I think that's it. Then we have a plan for this document. And I'll go and work on that. Okay, thanks.
Thank you. So the next presentation is radius attributes. Oh, no, I don't think it's the next is a different. Sorry. That's the right one. So,
thanks, Valerie.
Mark?
Yep, thanks for that. So this is a new draft 00 called a syntax for radius connect info attribute using Wi-Fi networks. So connect info is in 2869, and it says UTF-8 describing the nature of the user's connection. And so here we're looking to, I guess, define some syntax for that particular attribute. And so authors, self and Sri from Cisco, Josh from Cable Labs, as well as Michael Sim from Single Digits, and Bruno, of course, from WBA. Some of this work, I guess, started in WBA, and now it's in draft. Okay, next slide, please. So some of the motivation for this piece of work, we see increasing adoption of radius between separate administrative domains. We recognize that if you're in a single AD, then obviously you understand how your networks are configured, provisioned, set up. It's not an issue, but if we're between separate domains, this is more an issue. Increasing adoption of radius without a bilateral agreement. Obviously, if you've got a bilateral agreement between a NAS and a AAA, then you can negotiate anything you want in that AAA agreement or bilateral agreement. But now we're seeing increasing use of radius outside of bilateral agreements, in particular when we just have a single federation agreement, as we see in these Wi-Fi federations. We're increasingly seeing more and more complex wireless environments, so multiple overlapping networks. Those could be overlapping Wi-Fi networks, but equally some scenarios when we've got Wi-Fi networks overlapping with 5G networks. We've got more diversity, so that could be Wi-Fi generations, it could be spectrum allocations. And so what we hear speaking to AAA or credential providers is they want to ensure their users get a great Wi-Fi experience. So how do we do that? We think we can benefit the whole industry by defining a consistent framework for sharing visibility of these Wi-Fi network metrics between different stakeholders. And then after all, this is about driving adoption. So we think if we provide that insight, then we're going to drive confidence in that Wi-Fi service and drive adoption. And I should say that some of this work has led to WBA establishing a particular project called Access Network Metrics, where some of this work has been discussed. Okay, so that's the motivation. Next slide, please. So how best to share access networks metrics? So we could do non-radius approach, and we know, gRPC with protobuf is being used to share real-time information, 0MQ again in other vendor implementations, but really those require bilateral agreement for those particular approaches. So if we look at radius, we could define a brand new attribute. We think that could necessarily lead to slower adoption, as obviously we need all the OEMs to then support that. Or we can define a syntax for existing Connect Info. Connect Info is widely supported on Wi-Fi APs, host APD, and the like. So we're looking at defining a syntax for Connect Info to address this particular opportunity. Next slide, please. So just some examples of existing implementations. And so you can see these are 6 different implementations, and without any syntax being defined, they broadly adhere to starting off with the text connect, following by some speeds, following by some 802.11 flavors. We see other implementations that have added to that with, you can see that RSSI information, channel information. So we could say that already vendors have recognized the benefit in sharing this type of information in radius packets. The opportunity then is to define this syntax more concretely and allowing the current implementations. So we want to encompass those current implementations, but also supporting new optional key value pairs to address new requirements, new use cases that we see. Next slide. So what type of information are we looking to share? Some of that information relates to the Wi-Fi access network itself. And so we saw that, for example, in one of the implementations saying Wi-Fi channel number. When we go to Wi-Fi 6, because we start reusing channel numbers, we need the band as well. It could be the noise floor being experienced by the Wi-Fi access network. It could be channel utilization. It could be some of the configuration. For example, a typical configuration value is what RSSI min. You will respond from an 802.11 perspective. So we could share access network information, but we could also share station to AP information, such as RSSI, transmit bit rates, receive bit rates, frame loss, and frame retry. And some of these information key value pairs are applicable to a Connect Info in access request, but equally some are only applicable to those in accounting request type sort of interim and stop. So if we look at those that require multiple frames, like frame loss, frame retry, when we're looking at percentages, we don't see those as really being applicable to be in access request, but more account request, interim and stop. So next slide, please. One of the challenges we face is, I guess, from an 802.11 perspective, some of these metrics are, let's call it, loosely defined. And so if we want to start to compare metrics between different implementations, do we need to take into account the actual algorithm used by that particular implementation in creating a metric? So an example, an easy one is channel utilization. So typically you'll be able to configure your channel utilization average period. And so that's obviously in the access network that configures that. There are obviously other metrics used to configure other values within the access network. And so the challenge we face is, well, should we avoid sharing that information when there's some sort of diversity in implementations of those of creating those metrics, calculating those metrics, or do we allow to share the actual algorithm information, which then helps in comparing implementation 1 to implementation 2? And so the draft 00 permits sharing of algorithm information on a subset of these key value pairs. Next slide, please. And so, yeah, the draft really is just an ABNF syntax for which encompasses the current implementations. So the connect XX megabits per second 802 flavor, and then enhances it with optional connect attributes, which then address these new use cases. And so just on the right-hand side, you can see the example connect info. So the first one is a current implementation, and then we add that with RSSI min. We add it with the information about RSSI, how it was calculated. Going down, you look at channel utilization, how that was calculated, as well as the noise. And so more and more information that can be encoded in Connect Info. We also looked at host APD, and so we did a fork of host APD, and it's relatively trivial to be able to add these to the radius portion of host APD, so you can then easily share this information from a proof of concept perspective. So I think the last slide is next steps. So next steps. Okay. So I mean, we'd welcome comments and feedback on the scope. The scope is to propose this as informational. We'd like to hear about other implementations of Connect Info. I guess it's not exhaustive in terms of what we found already. So we want to encompass current Connect Infos. We want all those OEMs that currently support Connect Info to say, yes, we're aligned with this draft moving forward, albeit that we don't support some of the optional Connect Info attributes defined in the draft. So that's number one. Number two is, from a RADEXT perspective, is it in scope of RADEXT? And we look at the current charter, helping to address current goals of defined best practice for radius roaming. Clearly, this has been brought up from a WBA perspective, focused on radius roaming. You can see that between the different administrative domains. So is this within scope of the current charter? And then just from a timeline perspective, we appreciate, I guess, the workload of RADEXT, and from a timeline perspective, we think progressing the draft can accommodate the current RADEXT priorities. But really, yeah, interested in people's feedback as to whether you think this is useful and how best to proceed. Thank you.
Comments? Not a lot. I think hearing none. Oh, Hecky. There.
Yeah, this is Heikki. So I think it's good when things are clarified. I don't see a problem there. And so far, I think this is one of the attributes that is usually being just stored somewhere and maybe not being processed that much. So now it would have more value. And I guess one thing that I just thought that because it has things like noise loss and utilization, did you take a look at the existing implementations that have they has the Connect Info been the same in all accounting messages? Because now it seems that it will change between entering updates and between messages because it measures something active.
Yeah, so I guess that's a good point. I mean, so we see different implementations. So I think one OEM only does Connect Info in accounting request, and then others only do it in access request. I guess we've got to look at those that do it in both and to ensure that they, I guess, get updated values. But yeah, we see, I guess, a variety of deployments out there.
I have a question just on the beginning. You mentioned that it was formerly in the WBA and now it's coming here. That can be fine, but I think there's a little bit of a process we sometimes follow, and I don't know the steps to make sure that if it was, was there a draft of this submitted to the WBA, or how did it go from there to here? Just
yeah, Margaret. Yeah, so because of the timing involved, and so normally, I guess WBA lays into IAB, which would then get sort of punted to RADEXT. Because we were short of time before Dublin, we didn't take that approach, but we can obviously follow up with that liaison via the IAB channels. So the WBA document has drafted the ABNF, and so that's been taken out of that and used to create this draft. And so it's been discussed in WBA and their agreement on the Access Network Metrics team to take this particular approach to make this submission to IETF 121. Josh Redmore is leading that project in WBA, and so we wanted to, I guess, expedite the discussion of this topic within IETF whilst also progressing within WBA as well.
Well, obviously we put it on on the agenda, and we're not trying to block discussion. We will need to do some back channel stuff, I think, just to make sure. We would never want to get in a situation where the WBNA, whatever it is, BA, where they had intellectual property and we absconded with it. So, but usually that can be easily taken care of if the working group wants to send it here. So I already wrote a mail right near the beginning of the session and we'll just talk between the AD and the document authors and me and Valerie and figure out what's, it doesn't have to be a big process, right? It can be as simple as an email that everyone agrees to. And we will take that offline.
Thanks, Margaret.
I was just wanting to try and understand the reason of having the connect info in all the accountings and interim accountings, just for the remote server to be able to remote disconnect a user at some time.
We just refer to 2869, Gaetan, that you can have multiple connect infos in accounting requests. So, and we see vendor OEMs supporting that. In fact, one vendor supports it in accounting requests and not access requests. So we just, I guess, refer to 2869 when both are permitted.
Okay, but what I'm basically asking is coming back to the use case of how it would be used. I mean, instead of just referring to what's there. I mean,
Okay.
if we're defining a syntax for a specific purpose,
right?
Let's clarify the purpose.
Right. So there is to reflect, obviously, say in stop, so in access request is what's my user, what experience is my user likely to experience. Obviously in stop is what experience did my user experience. And then obviously, a credential holder, AAA service provider can use that in their processes to improve their systems.
So I understand what you're saying on the access request and on the stop, but in between the access request and the stop, there could be a huge variation of user experience. So in the stop, you may get an average of what he's experienced, but it could have been varying totally.
Right, indeed. I mean, interim, I guess, is 10 minutes minimum, and maybe 20 minutes typical. But yeah, so I don't know how useful interim is, but it's there.
Yeah.
I just want to. Oh, go ahead.
Yeah. I just had a question about that. I looked at the kind of connect info examples there, and I was wondering that if you had any ideas how that would fit into the connect info radius attribute length there.
Yeah, so good question, Carrie. All of those are within 253. I think all of those examples are below 180 octets, so well within 253.
I guess at least a semi-technical comment. You talked about sending these in accounting requests. I think there's a whole bunch of known issues with accounting at this point that are up on the Radius Known Issues wiki. And I think we'd have to consider this within, have you considered those issues, like the fact that it can't always deterministically, an accounting request can't always deterministically be connected to a particular session and so forth? And found that it's going to work for you to use them in accounting requests in real life.
Yeah, I guess WBA have got some best practice, I guess, in terms of being able to ensure that. But yeah, so to answer your question, no, I didn't look at that sort of issues list, but yeah, I will go away and look at it. Thanks.
Okay. That's good, I think. Valerie? Oh, you're still on mute.
We have the last presentation. Okay.
Okay, there's a new topic, radius attributes for NSEP or National Security and Emergency Preparedness Services. Myself, Sri Kundavelli, my co-author, Mark Grayson from Cisco, and Subhi Das from Paraton Labs. Next slide, please. So the larger context here, I think, this again relates to the work that we are doing in WBA, Wireless Broadband Alliances. So if you look at today where Wi-Fi is everywhere. It's currently carries more data than what cellular access carries, right? So there have been very good improvements around roaming or support of pass point profiles, QoS, location services. So now there's a view that Wi-Fi can deal with more mission critical type of services. So if you look at cellular architectures today, I can take a handset, I can make an emergency 911 call, right, from anywhere, I, without any subscription. I can pull out the SIM card, I can make that call, right? Or the other example is priority services. If there's a situation here, emergency personnel can walk in, they'll have prioritized access to the medium, meaning they can preempt everyone else. They can have, because of the situation, emergency situation, they can have prioritized access to the cellular services. So there are well deployed services around the globe, right? Now there is an interest from almost every, the government, the entities which deal with emergency situations to extend these services to Wi-Fi, because Wi-Fi is everywhere, right? I think there's some examples where in UK, right, today if there's some issue in the building, they'll bring in some huge equipment that stays outside with the cell towers, right, that provide connectivity. I think, but if there's already indoor Wi-Fi, if you solve the attached problems, potentially they can use that access. I think that's the larger context of this work. Again, two things: emergency 911 calling and priority services. The focus of this discussion topic is the later one, priority services. Next slide, please. So again, just focusing a bit on the NSEP services, national security and emergency preparedness services. If you look at it, again, the medium can be congested because everybody's trying to make a call or trying to attach. In that case, if the emergency personnel come in, they should be able to have access in priority access compared to everybody else, because they're trying to attend to the situation. So now these services are deployed by, like, all, at least if I look at United States, right, these are some of the large carriers like AT&T and others support these services, and the entities like DHS, CISA, which they're all the involved players in the overall ecosystem. Now next slide, please. So if you look at, these are services which are deployed: GETS, WPS, NGN priority, right? These are, like, I think a lot of this came into, like, after 9/11, right? Many of these people understood the importance of the services after this issues, right? So equally, they're not just limited to United States. If you look at globally, other environments as well. Next slide, please. So you have in Belgium or in Czech Republic, all of these countries, there are different services, but architecturally, what the functionally, it's they all provide the same service, like what it's prioritized priority services. So now coming back to Wi-Fi 7, next slide, please. Yeah. So let's look at what's happening in IEEE. IEEE 802.11b has defined something called EPCS, Emergency Preparedness Communication Service. They have defined the semantics that allows a station to have priority access to the medium. Meaning, the way it works is the access point provides a different set of EDCA parameters for EPCS clients. That allows, those EDCA parameters are like essentially, when there's a collision, my backoff timer is different than all other stations. I can come back more quicker, if I try to access, but at the end, these EDCA parameters will give me greater access to the medium. That's the underlying thing. Now, when that was discussed in all of this, right, I think the question came up, right? How can an access point decide when to authorize EPCS access or not? You can be an emergency personnel or not, right? On what basis you're going to authorize? I think this was a huge sticky point, right? Now, let's compare with what is there in cellular access. Cellular access, there's authorizing agent. That agent with interfaces to the carrier authorizes the transaction, right? If an emergency personnel come in, yeah, your emergency SIM, it's validated by a federal entity which is which manages this, right? That what we are trying to do is we are trying to exactly mirror that and bring into Wi-Fi access. That's the goal of this. So that way, right, we are not changing the fundamental, the cement, the backend interface are the same. It's just that we are bringing an authorization element. When an AP says, a station cannot attach twice station in the vicinity of an AP says, I need priority access. Well, I do not know. Let me go to the identity provider, right? If that identity provider is a designated entity, and if it authorizes that transaction, yes, the APs can say, yes, I'm giving you access because it's not my decision, but it's an entity which is, which is legally allowed to authorize this, right? So what the gaps are essentially, how do we, what do we need on the radius infrastructure to enable this? Next slide, please. So there are two aspects here. I think now just a bit on the how this prioritization happens. On the upstream side, like I said, a station authorized for EPCS gets a different set of EDCA parameters, right? That by virtue of that, it will have higher access to the medium, it can transmit more, right? On the downlink side, the AP has a logic which says that if I have many packets to forward, or right, but it will ensure that the priority is for the downstream flows for the EPCS authorized flows. So how it manages the scheduling on the downlink side. Now, next slide. I think that's the basic logic. Right? What we are, if you look at the functional flow, there's a capability exchange. Station says I'm capable, AP says I'm capable. Then station says, okay, how does I want authorization, right? We go to IDP, or in the radius says yes. I see that this is a valid client. It's allowed for EPCS, right? I'm authorizing this transaction. Now the AP based on this, I think that's a missing part. I think what you see is the grant part, the authorization grant from an authorizing agent, right, to coordinated through IDP is the missing elements that we are trying to bring in, right? Once that is authorization that is there, now this is identical to what is there in cellular access, right? It's the same structure and semantics, right? Right now, a bit on the radius. Next slide, please. Yeah, the overall, if you look at the call flow station, and there is a Wi-Fi access point and a AAA server, and then an authorizing agent, right? When a station comes in, it says for the EPCS, I need EPCS access, whatever it may be the semantics on the 802.11. But step 3 is where we indicate that NAS is capable of EPCS. We have defined some things, and then the if dialog, and finally the access accept will include a subscription info which says that what the station is authorized for, a priority level, and other things. This is the high level flow of what the exchange is. Next slide, please. So if you look at the proposed attributes, there next slide. Yeah, sorry. Yeah, the one is the capability indication, right? All the semantics here are if the station is capable, and if the AP is capable, right? There are a couple of the values that we have defined. If the NAS does not support EPCS is one considered scenario, right? Or the provider of the NAS is elected to support priority. Let's say station is not EPCS capable, but still potentially can prioritize the flows on the downlink side, right? So there are some semantics that we need to work out. These are all not cut out in a right. They're up for further discussion, but largely we are thinking along these lines, right? I think define the semantics where indicate the AP station's capability around this, AP's capability around this, right? Define few things. Next slide, please. Then the subscription info. This is largely we are mirroring what is there in cellular access. Again, the priority level. Cellular defines priority level 0 through 5, and I think there in some countries we have noted that it defines 0 to 7. Maybe what we are thinking is to include a country code in here, and that way the priority level that's indicated aligns with the country code that is signaled in the subscription info. Next slide, please. Now, this is more in the initial I think we need few more things. Like I think in some cases, maybe the IDP says I don't want to authorize everything for EPCS access. Maybe only certain flows, maybe a voice flow to certain realms, use it for priority access. Everything else will not go on the priority access, right? So for that, maybe the AAA can signal a filter, right? That filter identifies what flows are authorized for EPCs. And I think if there is a way to, monetization is always a discussion point, because in a Wi-Fi networks, why am I giving access? I think if we want to provide semantics, we want to say that, I've allowed this EPCs access to these stations at this time, and this was a usage, right? That means that in the accounting flows, we should be able to indicate something which the IDP can link all of this to an EPCS session. I think that's one thing. And finally, the invocation. I think the invocation is like, in some cases, like, invocation can be through a backend system. Perhaps maybe the use of COA to invoke an EPCS. I think, first thing is a capability exchange, but that does not mean it's automatically the session is invoked, right? The invocation can be explicit. It can be triggered from a station or from a backend system, right? For backend system, we are thinking of like using of a COA for invocation. We are draft. We need to submit yet this year. We need to do some more work. But this is the background of this. I'll take any questions, comments.
Yeah, I think we're actually out of time. So I'll turn it over to Valerie for final comments.
Thank you. So brings us to the list, because the draft isn't published yet, and it's better to first publish the draft and then have some discussion about this. And so thank you very much. We are a bit late past the time of the session, 1 minute. So I think it was a productive meeting, and thanks to everybody, and we'll continue to work.
Okay, thanks everyone.
Thanks. Bye-bye.